I work for Google in Zurich. I've been there for about just over 10 years now. And I've worked on a wide variety of systems in my tenure at Google. I started out working on the web crawler, on the web search indexing system, the logs processing systems. Worked on Google Maps, Google Calendar, Google Sites. Right now I manage the team that runs Google's payments and billing systems. And I try very hard not to think about how much money is being moved through those systems every year. So this talk is building blocks for site reliability. And before we go into the building blocks, we first have to talk about what site reliability engineering actually is. Any of you have this? We just wrote a book about site reliability engineering. Anybody have this book? If you have it with you, I would be very happy to sign it for you. Because I do have a chapter in that book. So what is site reliability engineering? I was at SRECon in Dublin this year, which tells you one thing about site reliability engineering. It's big enough to have its own Usenix conference. But also, at SRECon, there was a panel discussion entitled, "What is SRE?" And there was one question that was not answered during that entire discussion. And that question is, what is SRE? So in that sense, the discussion kind of failed its goal. And if you look at Google's own material on the topic, you get these sound bites about what is SRE. There's one from Ben Traynor, our VP of Operations, which says SRE is what you get when you treat operations as if it's a software problem. There's one from Andrew Widdowson, who runs our education programs for SRE. Says, "Our work is like being part of the world's most intense pit crew. We change the tires of a race car as it's going 100 miles per hour. You can tell that he's American because he thinks 100 miles per hour is actually fast." There's another one that says, "SREs engineer services instead of binaries." Me and a couple of co-workers have been trying to come up with a sort of brand statement for site reliability engineering. And the best we could come up with is site reliability engineering is a specialized job function that focuses on the reliability and maintainability of large systems. So it's a job function that is specifically geared towards reliability. As I said, Google has kind of invented the term, which means that we also get to define it. But also, talking with people in other companies, it turns out that how companies implement site reliability engineering is wildly different. So there's a ton of different engagement models for how you can implement this job function. And I've seen companies that have this sort of embedded site reliability model where you have like one or two site reliability engineers embedded into product engineering teams. There are companies that don't really have SRE at all, that have something like production engineering that actually do not engage with the products at all, but rather write infrastructure and platforms for achieving reliable systems. So I'm just going to talk about how Google implements SRE. And the way Google implements SRE is the following. SRE at Google is its own department. It's part of Google's technical infrastructure organization. And SRE has less than 10% of the engineering staff of Google. Usually it's about 5 to 10%. Or historically, it's been 5 to 10% of the engineering staff of Google. And individual SRE teams partner with product engineering teams in a sort of co-ownership model of the services. Usually it's a one-to-many mapping, so you will have one SRE team that is responsible for working with a number of services. And the size of the SRE teams compared to the size of the product engineering teams also varies widely. The best I've ever been in had a ratio of 1-to-5 between SREs and product engineers. That was incredible. That was really nice because you basically knew everybody by name. But I've also been in teams that had a factor of 1-to-50 between site reliability engineers and product engineers. One of the things about SRE is that makes it hard to implement SRE in the Google models is that SRE teams at Google come in a minimum size. If you have an SRE team in one single location, you need at least 8 people. If you have an SRE team that's split across 2 locations, then we try to have at least 6 plus 6, so 6 people in one location. And the reason for that is that SRE does emergency response for the services supported by a team, and we try not to burn our people out on emergency response, on on-call response. If you want to have a sustainable rotation for emergency response, you need a certain number of people. You don't want people to be on call all the time, or one out of every 2 or 3 weeks. So we aim to have at least this 8 or 6 plus 6 model. And this also means that SRE teams are very often not co-located with the product engineering teams. So in a single site SRE model, you can still kind of achieve that, but as soon as you go to multiple sites and product engineering is in a single site and site reliability is in at least 2, then you're not going to have co-location. And for a lot of product engineering teams, this is actually a big change in approach, that they're used to basically having everybody they interact with be down the corridor from them, and suddenly they need to interact with people that are in a different time zone. SRE recruits from both software engineering and systems engineering backgrounds. So, and there are no organizational barriers between product engineering and SRE for software engineers. So if you get hired by Google as a software engineer, you can freely move between product engineering and site reliability engineering. The other background that SRE recruits from is systems engineering or systems administration. And we basically recruit on the entire spectrum between software engineering and systems engineering. So we also recruit a lot of people with like a mixed background that maybe don't quite meet the software engineering bar at Google, but make up for this by being really good systems engineers. And yeah, and so because of this, the reason why we recruit for this background is that there's a mix of operational and engineering work in SRE, and there is a cap on operational work for an individual site reliability team. So the official cap is 50% operational load. This is where we pull the emergency brakes and offload operational work to the product engineering teams. Healthy teams have a much lower operational load than 50%. Usually we aim for 10 to 15% operational load. So, one thing I also wanted to mention is, what about DevOps? That's a term that very often gets thrown into the mix once you start talking about site reliability engineering. And I've noticed that Google has this institutional blindness when it comes to the term DevOps. Because we look at the DevOps principles, and we look at the DevOps toolchain, and we look at the DevOps lifecycle, and we sort of tilt our heads and we go, wait, isn't that how you do things? Because Google has no traditional IT. Google does not have ops. all of dev at Google is DevOps. We simply do not operate in a model where we have traditional IT. So pretty much all the DevOps toolchain is stuff that we do anyway. And a large part of that, of the DevOps toolchain is covered by site reliability engineering, especially when we're talking about automation, when we're talking about monitoring, when we're talking about releases. A lot of that is covered by site reliability. That being said, let's look at the building blocks. Let's look at how you get a reliable service. I said that site reliability engineering is a specialized job function focused on reliability. So that means that SRE is likely to engage in fields that make the biggest difference to the reliability of a system. And these are basically the building blocks for SRE. What do you need to do if you want to get a reliable service? And I'm going to talk about a couple of them in the rest of this talk. The others are in the book, if you want to read that. First of all, if you want to have a reliable service, you need to know how reliable it actually is. And that means you need monitoring. You need something that tells you how reliable is my service at this point in time. And same for improving reliability. Unless you know how reliable it is, you have nothing to improve. And unless you have alerting, you can't actually step in when things go wrong. Unless people call you on the phone and tell you that your site is broken, but you don't really want to get to that point. You want to know that your site is broken before your customers notice. And all of these things make monitoring and alerting a very attractive target for SRE. So SRE typically writes the monitoring for their own services, writes the instrumentation, does black box monitoring for the services, reviews and tunes alerts, and so on. So it covers the whole telemetry and instrumentation part. What else do you need? You need service level objectives. Well, monitoring tells you how reliable your service is. Service level objectives tell you how reliable you want it to be. And service level objectives serve as the goal for the SRE team to strive for. And also as a reference point for how much we actually want to invest into reliability. So typically, a couple of words on service level objectives. Typically, SLOs should be set on customer expectations. One trap that very often you fall into when you try to set SLOs is you look at how reliable the system is at any point in time, and you're like, well, that sounds like a number we can reach. And then you set that as your SLO, and 2 years later, you've forgotten where that number comes from. And 2 years later, you'll be running a 4 nines availability service, and maybe your reliability is degrading, and you're starting to invest lots of effort into improving reliability. And then you look at your customers and you realize, oh wait, they actually won't notice if we drop a 9 or 2. And all of this work that we're doing is really for nothing. So you need to set them based on customer requirements. You need to document where they're coming from, because otherwise they turn into these magic numbers that nobody's willing to change. And you also need a certain amount of buffer in the service level objectives. Say you committed in your service level objectives to running a service at 200 milliseconds average latency. If you consistently run it at 190, then you have no room for error. And no room for error means that there's no room for change. You can't change the system because that might endanger you meeting your service level objectives. Next, the other thing that we need is automation, and Dimitri is going to give a whole talk about that. and just following me, I think. So automation, when we're talking about reliability engineering, has two facets. One of them is at the scale that we're talking about, automation is a sheer necessity. We cannot run our systems manually. We need automation. It doesn't work otherwise. So automation is what allows an operations team to scale. But the other point is, how does automation interact with reliability? And the way automation interacts with reliability is that automation takes the human error out of performing processes. It also introduces the possibility of computer error. And it also turns out computers are far more efficient at making mistakes than humans are. And they can make mistakes on a far larger scale. And also faster, yes. But with the crucial difference that computerized automation is testable. Processes executed by a human are not testable. Automation is. So you have the opportunity to address the problem of reliability of your automation the same way that you address any other software problem. You address it by testing. Google had a phase in the SRE development where we focused a lot on automating existing processes. Basically, you went from a manual failover procedure that somebody wrote down and followed whenever we needed to fail over to a different data center. You went from that to a script, and then you went on to a kind of more fancy script and a more fancy script, and frameworks around the scripts, and more tests and more tests and more tests. At some point, we realized that automating processes designed for a human to execute does not really scale. And these days, we're investing a lot more effort into building systems that either are designed with automation in mind from the beginning, or that don't need automation at all. So, to pick the example of the manual failover, well, we can design a system for manual failover, and we can automate the steps needed for that failover. But we can also design a system that runs in a hot configuration where all instances of the system take part of the load. And if you spread that around enough, then one of the systems going down is not a failover anymore. It's just a loss of capacity. And we do capacity adjustments all the time anyway, and the system is just going to deal with that in the course of its normal operations. So at that point, we're ending up with a system that does not need automation, because what we use to automate is part of the normal operations of that system. Next one, releases and config management. If releases and config changes are the thing that causes most of your outages, then that is an attractive target for site reliability engineering. So early on in Google SRE, site reliability engineers would often act as gatekeepers for changes to the production systems. We would get new binaries to be deployed from the product engineering teams. We would get configuration changes from the product engineering teams, and site reliability engineers would review these and test them and roll them out carefully and monitoring and make sure that everything went well. This is, if you're in an early life cycle of an application, this is an incredibly effective way of improving reliability. It also doesn't scale. You burn a lot of manpower just on playing this gatekeeper function for the production systems. So in recent years, what site reliability has focused on has been mostly building infrastructure that allows you to make these kinds of changes safely and reliably. And Once we have the infrastructure up to a point where the changes are either safe or they will get rolled back automatically, then we can just give the responsibility for those changes back to the product engineering teams, which makes the site reliability engineers happy because they don't have to burn their own manpower on making these changes. And it makes the product engineering teams happy because they don't have to talk with site reliability anytime they want to make a change. And everybody is happy. Next one, on-call and emergency response. So, talked about monitoring and alerting, the thing that allows, well, what allows you to detect when something is going wrong in your systems. Once you've detected it, you need to fix the problem. And for the services supported by SRE at Google, that is usually site reliability engineers that get paged and then do emergency response. So basically, anytime something is wrong with Google Web Search, Gmail, whatever, probably some SRE's pager is going off somewhere, hopefully already. There are also some organizations that practice a shared on-call model where you have members of site reliability engineering and product engineering sharing responsibility for emergency response. Turns out, because of the size mismatch between site reliability teams and product engineering teams, this is surprisingly hard to implement. Because if you have a small site reliability team, 6 to 12 people, then everybody is on call reasonably frequently, at least once every 2 months. And people are very well trained and very well versed in emergency response. If you try to scale this up to a 600-person product engineering team, this is not going to work because people are never going to gain the expertise they need for emergency response because they're never on call frequently enough. So this mostly works in very small product engineering teams. What a lot of product engineering organizations do is they employ a secondary on-call rotation as an escalation point for site reliability engineering. So if there is a problem that site reliability can't solve, then we can escalate to the product engineering teams. Site reliability only tends to engage with services that need an on-call response time of 30 minutes or less. Basically anything larger than 30 minutes is usually not worth staffing a site reliability team for because of the minimum size that I mentioned. SREs are incentivized to keep the number of outages or the number of incidents per shift to less than 2. Healthy teams, again, have a lot lower number of incidents per shift, usually around 0.1 to 0.2 per shift. So one of the advantages of having on-call and emergency response with site reliability engineering is one I've already alluded to, which is that you get a small team that is very well trained and very well practiced in this kind of emergency response. But there is another more subtle advantage of having emergency response in a different team, which is the following. It forces the product engineering teams to get their services into a shape where they can actually reasonably be taken care of by somebody who is not a core product developer. So usually when SRE starts engaging with a new service, that service goes through an intense period of service hardening and improving the processes around running the service so that a different team can actually meaningfully do on-call response for that service. Next one, capacity planning. How does capacity planning interact with reliability? Well, if you run out of capacity and you overload your service, gonna lose reliability really, really quickly. So capacity planning traditionally also is site reliability engineering territory. So site reliability engineering does the demand assessment, does the forecasting, does capacity assessment via load testing, provisioning, and also maintaining all the infrastructure around it to do this automatically. Data integrity is possibly one that doesn't quite seem to fit in there. Because, well, if the serving systems are up and running, and if they're producing valid responses, and if they have capacity, etc., then what does the data have to do with that? Well, from a user's perspective, data integrity problems and service reliability problems are indistinguishable from each other. The user doesn't really care whether they can't get their email because your front end is broken or because there was data corruption in your database. From the user's perspective, the result is the same. They can't get their email. So that's the reason why site reliability also engages with data integrity. So site reliability does things like making sure that all of the data stores of a service are backed up, that we have restore procedures, that the restore procedures are tested and executed regularly. Some services have automated continuous restore pipelines, where basically all the time we're storing a small part of the data and make sure that what we're getting back from the backup system is what we're actually expecting. And SRE also often maintains the pipelines that periodically verify the data integrity of the data stores. And with that, so that's a small sample of building blocks for SRE. Some of the parts that SRE engages in. Let's talk about what's next for SRE. What are the big challenges for SRE? One of the problems for Google SRE right now is that we've solved most of the problems. Well, that is not the problem. The problem for Google SRE is that most of the problems we've already solved several times in different parts of the company. So the big challenge is, how do we take the accumulated knowledge of more than 10 years of SRE and package it into something that scales across the entire organization, so that we don't need to solve the same problems over and over again. And I spent part of my career at Google in a department called Launch Coordination Engineering. Launch Coordination Engineering is a part of site reliability that engages with new products and new services at launch time, and basically makes sure that they're reliable from the start. That we don't launch train wrecks from the reliability perspective. And one part of that job was looking at the engineering teams. So this was 4 to 5 years ago. One part of that job was looking at the product engineering team's requirements and listening to what they wanted and what problems they were trying to solve, and then saying, oh yes, this engineering team in this other part of the company has already solved that. Go talk with them. Oh, and this problem, yes, that engineering team has solved that one, and this other engineering team has solved. And for the other 4, we have standard libraries that you can just implement. And this is the mode of operation that we want to get out of. We don't want to have this hands-on approach, this hands-on attention to every service that we run. Because the number of services at Google is growing a lot faster than the number of engineers. And we want to even accelerate that growth. We want to go to more microservices and automate more of the service management and the service deployment. So we cannot afford to give this sort of individualized attention to every service. So how do we make that scale? Well, 2 ways we can make that scale. One of them is baking more than 10 years of SRE experience into Google's frameworks and into Google's libraries. So that either the engineer doesn't have to look for solutions or write them themselves, but can just turn them on because they're in the framework anyway, or in the best case, they don't have to do anything because these solutions are on by default everywhere and you don't have to think about them. So this is the one approach, baking it into the basic libraries and the frameworks. The other approach is standardizing. We're at a point where in SRE, it doesn't make sense for us anymore to solve problems for a single team. It doesn't even make sense anymore for us to solve problems for a single product area. If we want to solve problems, they have to be Google-sized. They have to be able to scale to the entire organization, to the entire company. And one way of doing that is standardizing. Basically providing a production platform for the product engineering teams to run their services on, where SRE provides support for the platform and the product engineering teams run their product on that platform. And I think with that, yeah, so this has kind of shown, and I've mentioned this a couple of times in the talk, that site reliability used to do things a certain way. Now we do things differently. We have plans for the future. We have plans how to scale our work. So in reality, what is site reliability engineering has no fixed answer, because the targets that are most valuable for site reliability engineering change over time and change over the years. And we're trying to adapt what site reliability engineering does to the changing requirements in the environment that we operate in. And with that, I would like to conclude my talk.